Hello everybody, welcome to the first event in the Encode Worldcoin Educate Series. It's so lovely to see you that you joined us for this first event. And first of all, I want to introduce myself. My name is Devin. I'm an operations manager at Encode Club. And I'll be hosting today's session before your actual program mentioned for the series is back on Wednesday. So a couple of words about us as a company. We are a global Web3 education community, which basically means we organize different kinds of events, educational events in the Web3 and AI fields. And through these events, we hope to advance your careers in these sectors. We do this through different kinds of educational events. The Educate series, education series like this particular one, was the hackathons, was the accelerators, was the bootcamp, was the recruitment stuff, and a couple of other side things as well, like for example, in-person hacker houses, in-person hackathons, stuff like that. And over the last couple of years, we're very proud to announce that over 500,000 developers have gone through our ecosystem. I assume most of you are not new to our communities, which basically means that you've seen all this already. But let's go to something new, which is the event schedule for this particular educational series. Today we are starting with Introduction to Worldcoin by dcbuilder, who's here with us on stage already. And then we will be talking about all hardware and software on Wednesday. Next week, ZKML and MPC and Biometrics. And then the week after that, we'll be talking about the World ID use cases and SDK cryptography. And finally, 3 weeks from now, and during the final week of the series, we'll have 2 final events, one on World Chain and the LP stack. And finally, we'll finish things Wednesday, the 18th of September, with the future of work and technology also from dcbuilder. So yeah, that's pretty much it. Feel free to register for all of these or just some of these events on our webpage or our Luma pages. And yeah, we hope that you'll enjoy the next 4 weeks as we dive into Worldcoin. Finally, before we kick things off with the first session, a reminder to join our Discord channel, as this is where most of the communication with all of you will be taking place and where you should be if you want to get all the latest updates on the series, as well as be the first to get stuff like resources, recordings, and stuff like that. Cool. Thank you very much for listening in. I'll stop sharing my screen now, and yeah, I'll give you over to dcbuilder for the first session. Thank you.
All right, let me share my screen really quickly. I'll present. So can everyone see the slides?
Yes, perfect.
Awesome, cool. So hello everyone, I'm a research engineer at the Worldcoin Foundation. I go by this pseudonym called dcbuilder on the internet, and today I'll be talking about like Worldcoin, what it is, how it got started, why is it here, what are we trying to do, and some interesting things that we've been doing for the last couple of years. If at any point in time you feel like I should talk slower, or maybe there's some technical issues, or you have any questions, feel free to ask me over in the chat. The chat, I should be able to see any questions as they pop up, so I'll be able to answer them. And also there will be plenty of time after the main talk itself for you to ask questions, and maybe we can open it up to a more discussion Q&A format. An introduction to Worldcoin, right? This is a part of one of the 8 talks that we'll be giving over the next couple of weeks around different things within Worldcoin. Pretty much we're going to set the stage, right? What are the different topics we're going to be talking about? As Nevin mentioned, we have hardware, orb hardware, the software for the orb, we have biometrics, world ID use cases, cryptography, world chain, and the future of Worldcoin technology. In this presentation, I'll lay the groundwork for what these sorts of things mean and why is it important. So today I'll be starting with like why Worldcoin got started, why do we exist, why did it get created, and why do we think that building something like Worldcoin is valuable and meaningful and important for the future of the internet. So what Worldcoin is trying to do is to build the largest identity and financial network by giving access to everyone. So what does that mean, right? Like we've seen over the last decades, the financial system is broken down into many different systems that are each administered by their own countries. And in the last 10 years or so, we've seen the advent of public blockchains like Bitcoin, Ethereum, and many others that are trying to solve a bunch of different problems that we have in our current financial system, especially when it comes to decentralization, like individual sovereignty, like having control over your own assets, having transparency and trust, being able to validate the state of this blockchain or this like financial system, as opposed to having to trust some intermediary. And the equivalent also goes for identity, right? We've seen over time that as you use the internet, especially in the age of AI, now that you have a lot of like generative AI models, like modern LLMs, you can think of ChatGPT or Claude or Gemini, Meta's Llama. Like there's many different models, and all of them have started to become more and more powerful. And over time, people can use them to attack different systems by creating AI-generated content, which is indiscernible from human-generated content, which can impact a lot of services that we have on the internet, and would severely worsen the experience of most humans using the internet. So this is also like one of the biggest problems that we have nowadays, and is going to become ever more prevalent over time. And also for all the other identity solutions, all of them are centralized and they don't scale, they're not interoperable, they're not privacy preserving. So there's lots of issues around different parts of the stack, and we believed that there's like this immediate need for something that is able to address these issues. And so we started building towards this future. So why now? As I mentioned, AI is getting ever better over time, especially if you take the limit of where it's going. If you think of where it's going like the next 5, 10, 15 years, you can even achieve, most likely, you can achieve the state of AI, which is called AGI, or artificial general intelligence, where different agents, AI agents, are able to essentially be completely indiscernible from human beings. Like they have the same capabilities as a regular human being, and they're not able to be pulled apart. There's problems when it comes to building governance protocols. You've seen, like, maybe if you've interacted with any blockchain voting protocols or governance protocols for different DAOs, a lot of them have very little governance that is democratic. Most of them are plutocratic in the sense that I have one token, I have one vote, but there's very few like one person, one vote type mechanisms. And this sort of like inherently creates a need for humanness, either on chain or on the internet. And also, if you assume that these AGIs create economic value because they're participating in the economy, right? Like if you have intelligence, you can create economic value. And if you create economic value that is created by AIs, then there's like a natural question where it's like, who should be the beneficiary of that value? And so if you want to have some form of maybe like an experimental UBI process where you can distribute the revenue that is generated by AI, you also need to have some form of humanness oracle that is able to tell you like, okay, one person, one share of some specific thing that is generated by AI, be that economic value, be that some other output that is valuable. So what we're trying to do is to deliver on this global promise, right? This original promise of scaling a global system that is able to be inclusive for everyone, like it doesn't discriminate. It should be able to support billions of humans, billions of users, unique users, and it should be able to provide you this sort of like identity primitive that allows you to prove that you're a unique person on the internet and on chain also as well. So the way that we do that is with a different set of tools. So Worldcoin, when it got started originally, it was mostly like solving the personhood problem. Right now, I'll introduce like some of the things that we're building at the moment, like the main product line, if you will. So the World app is like the hub for anything Worldcoin. If you want to interact with anything that was built by the Worldcoin team or like within the Worldcoin mission, then this is like the interface for that. So what the app does is that it's an interface for you to interact with our identity protocol. It's an interface for you to interact with the wallet and also with the Worldcoin token as well. So essentially, it's the first wallet that we developed as part of the Worldcoin ecosystem. It was developed by Tools for Humanity. So for context, I work at the foundation, Worldcoin Foundation, and Tools for Humanity is the entity that is the building, the first contributor, and a lot of the founding team comes from that team. So they're the first team to develop like a bunch of different solutions, including the World app. As we go forward and we decentralize, ideally, there would be many different teams that build many different parts of the stack, including an alternative front end or interface. In the end, this is just a hub for users to interact with different services that we've built as part of the Worldcoin ecosystem. And so this is like the main place that most people interact with from day to day when it comes to Worldcoin, if you're a user, right? So either if you're an Android or an iOS, you can interact with World app. So World ID is this proof personhood protocol that we've built. It's a protocol that allows you to prove to anyone on the internet or on chain, on Ethereum or Optimism mainnet at the moment, but we're expanding as well. You're able to prove that you're a unique person. The way that you do that is that every user, when they get signed up at the orb, at this hardware device, which I'll get into later, every user gets creates a private public key pair, and they're able to then authenticate this public key once they're verified. And with this private key that they have on their phone, they're able to create proofs of personhood. They're able to provide a cryptographic proof that preserves their privacy. It's called the zero knowledge proof, which is able to essentially prove that you're part of the set of verified users. And this is what World ID enables. You're able to prove that you own a private key to a public key in the set of verified public keys of verified users. We call these public keys identity commitments, which is like every user has like a unique public key that is pseudonymous, and they're able to prove the ownership of them. And you can prove that they're part of a set of verified humans without revealing which specific element of the set they are. So essentially, this is the main enabler for building Sybil-resistant applications. So for those who have not heard the term Sybil resistance, I'll also type it out so that maybe the spelling is understood. So this is how you spell Sybil resistance. Sybil resistance is this property where if you want to build a protocol that assumes that some action within this protocol is unique, so you can think of like voting, right? When you build a voting protocol, let's say you have elections and you want to vote for a specific candidate, you only want the voters to only vote for one candidate. You don't allow them to vote for multiple. So this is one such like designed Sybil-resistant protocol. And the way that you usually enforce Sybil resistance in the traditional world is usually like having to do a KYC check where they check your ID, your voter ID, or like your, I don't know, like your personal identity card that is issued by the government. And then they're able to note that down that this person has already voted, and they allow them to vote, and that's it, right? The person, if they show up again to try and vote, people will check if they've already voted. And if the person has already voted, they will tell them they cannot vote anymore. This is sort of like the main property of Sybil resistance. However, if you want to build a Sybil resistance protocol, or a protocol that sort of enforces this property of one person, one action, it's really impossible to build that at a global scale with any solution that we've built so far. It's a very new set of problems because nobody has had to do this before, right? Like we always just assume that, okay, like on the internet, we might not necessarily need these things. But as we've become a more digital heavy species and we've started to use a lot of digital services for our day-to-day lives, these sort of properties become more important, right? Like if I want to do a vote about some important thing in a digital way without having to show up somewhere in person. Sorry, excuse me. I'm just gonna mute myself for a second. So yeah. So if you want to build a protocol that requires this property of Sybil resistance on a global scale on the internet, there's really no proper solutions. So this is what World ID is trying to tackle, right? We have a bunch of different integrations. Any developer can integrate World ID into their own application using our SDK called IDKit. If you're curious about that one, there is a link. Let me think. It formats the link correctly. That is the documentation for World ID if anyone is interested on how to integrate. But essentially, it's a toolkit and a protocol that allows you to essentially integrate this property of Sybil resistance. You can do any on-chain or web application that essentially allows you to make any action be Sybil resistant in the sense that you can only do it once or a given amount of times. You can repeat it maybe 5 times or 10 times or other ways. But you have this like programmable way of making sure that all of your users are unique users. And when they're interacting with your application, they don't have to disclose who they are. They don't have to show their ID. They don't have to show anything else. All they do is that they're proving that they're part of the set of verified users that Worldcoin has through the orb. Okay, let me get to the next slide. Over the last several years, we've been growing our user base. The way that we do so is that we have to manufacture these hardware devices and distribute them around the world. There's operators for them. And essentially, like, you get users to download the World app, and they interact with the Worldcoin ecosystem by either verifying their World ID or by interacting with the wallet and all sorts of different things. So the project got started around 2019, I think, because I joined later, so I'm not too sure about the exact date, but we started our beta during 2021, and we started onboarding users in a bunch of different pilot countries. And over time, we've expanded and grown and faced new challenges, because as you grow, a lot of the infrastructure needs to adapt. And so this is like what the current outlook looks like. So the more up-to-date numbers, this is all the way up to June. So currently, if you go to the worldcoin.org website, you can see the latest up-to-date numbers when it comes to users verified on World ID. So there's over 6.5 million World ID verified users at the moment when it comes to being verified by the orb, and about 13.5 or 13 million plus users that have downloaded the World app. And there's a rate of like about 8x of like year-over-year monthly active user growth. I wanted to also explain like how we've evolved in our on-chain thinking. Like, how do we start in the very beginning during our beta, and how do we grow? So in 2021, we launched on this custom solution that we developed internally. This is before my time. So it was an optimistic rollup. For those of you who have not heard or don't know, I'm not sure. Maybe if anyone that hasn't heard of what a rollup is, can you let me know in the chat? That would be great. Just so I know the context of how technical you guys are when it comes to like scalability solutions on blockchains and such. Essentially, rollups are the scalability solutions. I can also really let you know like this. There's this really good website called l2b.com, which explains a lot of things around these. So optimistic rollup, we built a custom optimistic rollup, which is a scaling solution on Ethereum. However, this scaling solution only supported payments, right? So it only supported people sending tokens back and forth. So you can send like USDC back and forth. And okay, you don't know what a rollup is. Okay. You can only send tokens back and forth and so forth. So let me backstep a little bit so I can set the context for you guys. Blockchains have this problem where if you want to have a lot of transactions like per second, you want to have a lot of throughput, allowing a lot of people to interact with the blockchain, there's a fundamental set of limits. If the blockchain wants to be decentralized, meaning that there's thousands of nodes validating the network that are verifying that every single block that is on the blockchain is valid, then they need to re-execute everything. And then since you have thousands of computers re-executing the same blocks and same transactions, there's a fundamental limit to like some computing bandwidth that you have where like the entire network needs to be in sync. They need to propagate blocks to each other. They need to achieve consensus on the blocks, either through proof of work, proof of stake, or some other consensus algorithm. And they need to have some form of economic security that sort of validates that, hey, these people cannot cheat when it comes to proposing new blocks. And so Ethereum has chosen to be really safe and really decentralized. So it's quite hard to do an attack on Ethereum when it comes to like value that you need to put at stake to be able to perform an attack on Ethereum. It's several billions of dollars. And the problem is that Ethereum also has this constraint that it wants to be verified by regular hardware, like hardware that is consumer friendly. Any consumer like you and I, we can walk into a store, buy a regular computer, like average computer, and we would be able to run Ethereum. We'd be able to validate Ethereum. That is one of the constraints that Ethereum was built with. And this creates a hard limit when it comes to like how much throughput you can have, because consumer hardware is only so performant. And so if you want to scale that, there is a bunch of different scaling solutions, which are called rollups, which are able to inherit Ethereum security through a bunch of different mechanisms. But this is essentially what a rollup is. It's a scalability solution that allows you to do more transactions on, let's say, Ethereum, whilst inheriting a lot of the security guarantees of Ethereum. So if you want to read more about rollups, I recommend you read more of this presentation. And we'll get deeper into rollups for one of our latest presentations when it comes to WorldChain. We have a presentation about WorldChain, and WorldChain is an optimistic rollup. Currently, we're in Optimism mainnet, which is also a rollup. So yeah, okay, so that's like some preliminary explanation about what they are. So when it comes to our own on-chain history, we built this like custom optimistic rollup, and this rollup only supported payments. So on Ethereum, you can have things like smart contracts, right? You can have programmable ways of interacting with the blockchain. You can interact with, for example, applications like Aave, Uniswap, right? I can borrow money, I can lend money, I can swap tokens on a automated market maker like Uniswap. I can do all sorts of different things. I can like mint an NFT. I can have a smart account wallet. I can do a bunch of different transactions with different logic. And so this is the feature of the virtual machine that Ethereum has, the EVM. Or for Solana, you have the Solana virtual machine, and other blockchains have their own execution environment that allow you to have this programmability within the blockchain. So for us, our first solution didn't have this. We didn't have a general programmable environment. We only supported payments. And the reason for that is that we thought that it was only going to be mostly important for people to just send payments back and forth. In 2021, it wasn't obvious because there was no applications on chain. So we mostly wanted to optimize for this throughput. And so we built a custom solution. However, over time, we realized that users really want to interact with things. We want to have things like automated market makers. We wanted to do swaps and things. Brian, I'll answer that question a bit later. Then we essentially realized that we want to have things like automated market makers. We wanted to have swaps, we wanted to have lending. We wanted to expose our users, or like at least allow our users to interact with on-chain applications. And so we migrated our infrastructure from this custom solution that we built called Hubble to Polygon POS. So Polygon is an L1, and it also timestamps its state on Ethereum. And so we launched on Polygon POS during our beta. So this was when we had around 700,000 users. And over time, we started like deploying our architecture of smart contract wallets. So for every user, we deploy a smart contract wallet based on this tool called Safe. Let me find really quickly if I can find in this other tab a link that I can send you guys. Safe. There we go. Sorry for this. I'm just want to share you guys like what it is so you can see. So it's a smart contract wallet that allows you to essentially interact with Ethereum, but instead of having an address on Ethereum, the regular address called an EOA, externally owned address, you have a smart account address. So you're able to do things like better recovery. You're able to do things like multi-signatories, right? So you can have multiple people own the same wallet and different things. So for every Worldcoin user that is verified by World ID, we have deployed one such smart account wallet called from Safe, right? Smart account wallet from Safe. And this allows us to do a bunch of interesting things like sponsoring transactions for them, right? So for every user that interacts with Worldcoin within the World app, they don't pay for transaction fees. And the way that we do this is through this Safe Smart account and this standard called meta transactions, which allows us to subsidize transactions for users. So when you're using World app, you don't pay for transactions. And then in 2023, around launch, so in July of 2023, last year, we launched on Optimism mainnet. So we migrated to this really popular optimistic rollup, and now we're part of the Optimism ecosystem. And as part of the Optimism ecosystem, we're expanding because since you saw the growth numbers, right, like these numbers, as we grew, we ended up consuming more and more block space, or like essentially space on Optimism to do transactions. And so we've reached some hard limits of like how much we can scale. And so we decided to launch our own optimistic rollup, which is part of the Optimism ecosystem, or the OP superchain ecosystem, which is called WorldChain. So this is a really like short hint of what it is. We'll go much more into depth into this once we have a presentation on WorldChain on its own. So yeah. And this is going to be launching this year. We've already announced a dev preview So developers can already start building on WorldChain and deploying their smart contracts. And as we migrate all of our user base from Optimism mainnet to WorldChain, then once everything is ready and all of the dependencies are ready and all of the applications that we need are there, then we're going to make it like a public mainnet announcement, which is going to come in some few weeks or so. So yeah, so that's like a brief history of our like on-chain story of like how we went from having a custom solution in our beta to expanding our beta to Polygon POS, and then eventually migrating to Optimism and now WorldChain. Essentially, all of these migrations happened due to some limitations that we had, where there's some really hard limitations when it comes to how much transactions we can do on this network, since we have like many millions of transactions for every single user. There ended up being more and more problems, and in the end, you need to have some ownership over some scalability parameters, and you need to have some ownership over some infrastructure so you can expand things based on your own needs. So as we had different needs and different constraints for building our application and building different Worldcoin services, then we had to expand to other places. So now I'll explain briefly what this orb is. What is this hardware device that we're building? Within the Worldcoin ecosystem, you have to have a way to prove that the person is unique, and that they're a unique person, right? So this is a really hard problem. If you can think of like all the existing solutions that you might have used, maybe if you fly a lot, maybe you've used things like Clear, which is this biometric scanner at airports. Maybe if you've voted for elections, maybe you have to show your ID. Maybe if you've interacted with some website, they have you like put your email address and do some verification, or maybe your credit card number or something. Essentially, there's different solutions that people have used to try and verify that the people interacting with the application are unique. However, all of these have become really bad at verifying uniqueness. So you can think of like a CAPTCHA, right? Like if I have a puzzle and I need to like quit, for example, I need to click on how many of these images are bicycles and I need to label them. You can think of AIs nowadays, like for them, it's a trivial problem because they've been trained, like convolutional neural networks have been trained on just, okay, this is a bike, this is a bike, this is a car. So it's quite easy to solve these CAPTCHAs nowadays for bots. And so all of these solutions that have existed in the last few years have really become overrun by AIs and other automated systems that are able to game this. So the orb is like this oracle or source of truth for what is a unique human. And so this is like why we built this. If you go through the set of existing solutions, none of them were really good. Maybe if I can, let me quickly find a quick, okay. I can show you like some, we have a good documentation in our white paper. And in the white paper, there's a really good graph that shows like why we chose to build our own custom solution as opposed to using anything else that already exists. So maybe if I'll find it, maybe I'll show that later. I'll go through the white paper after I finish through the slides. For those who are curious, also this is the link. Essentially, this presentation is like a diluted version of the white paper. It's a lot more succinct and more sparse. What the orb does is that it verifies that the person in front of the orb is a unique person and that it's a real person. So at first, it does this check that the person in front of the orb is a real person. As you can see in the image, there's a bunch of different sensors. There's a camera, there's a gimbal mirror, there's a calibration system, there's a custom lens, there's the motherboard with capacitors, and there's a battery, a GPU, a heatsink for the GPU. There's all sorts of different components, but what they all do in the end is essentially to prove that the person standing in front of the orb is a real person. The thing that is hard about this is that it's really hard to prove that not only this, but also do it in a privacy preserving way, right? You can think of like existing solutions, they are not privacy preserving because they collect some biometrics about you. When it comes to the orb is able to produce this thing called an iris code, which I'll show you later in the white paper. But what this iris code is, it's a representation of the uniqueness that is encoded in the iris for every single person. So essentially every iris for every single person is really unique. By unique, I mean that there's enough random information, like every single pattern on people's irises are unique. And so if you're able to create an algorithm that encapsulates this uniqueness without like leaking information or without leaking too much information, then you're able to essentially use this representation of the randomness, and you can match the randomness representation to other people's to be able to make sure that the person is unique. And then there's also a bunch of other checks within the orb itself, which allow you to prove that the person is not wearing contact lenses, glasses. It's able to essentially prove that the person standing in front of the orb is a real person. And the second part, using the iris code, is able to prove that the person is unique. The actual like technicalities of how that works are explained in depth in the white paper. And if we have some time, I have 29 minutes left, as I can see. Then maybe towards the end, I can show you some like specifics and you can have some intuition. All of these things are open source. So also like I can share you the links for GitHub for this. Open Iris. So this is, let me just double check that this link is correct. Yes. So this is the open source repo for how the Worldcoin Biometrics pipeline works. Then we have the orb hardware. So the hardware schematics for how the orb is assembled, what components and how it works. And then there's the orb software. In the next presentations, we're going to have people from Tools for Humanity who are working on different parts of this stack to explain these different components. Most specifically, Daniel Gershovich from the Tools for Humanity team will be explaining how this works. And orb-software. For those who are curious, we have like open source and published like how these things actually work, like what is it underneath. And within the white paper, you have technical explainers that explain like how this works on a high level. So yeah, so the orb does these two main things. It proves that the person in front of the orb is a real person, and it proves that the person in front of the orb is a unique person. And the orb is like this source of truth, and it's also the thing that enforces like the truth, right? And how you do that is that the orb itself has a lot of security mechanisms to prevent it from being tampered. You can assume that in an adversarial scenario, people can try and attack like the biometrics pipeline within the orb to try and create multiple identities or multiple iris codes and try and gain the system, right? So what the orb is, it has a lot of like security features that also prevent it from being tampered with on the hardware level, on the software level, on the biometrics level. There's different like security checks and tamper prevention checks that essentially enforce and prove that the person is actually real and nobody else can tamper with this. So this is like why we need to build your own custom solution, because if you can think of other solutions, let's say your phone, the problem with like, let's say Face ID, many people think, oh, why don't you use your phone? Why do you use Face ID? So the way that Face ID works, for example, is that the phone will do like a 3D scan, or like it will take a bunch of pictures in different orientations of your face and try and map that to a 3D model that will try and create. And then whenever you're unlocking your phone, it will match your frontal picture to that model and try and authenticate whether it's the same person unlocking. The problem with this is that it only works for like about 15 million people, right? So for every person that has a Face ID, so if there's 15 million people, there's 2 people that at least are able to unlock the same phone, because these systems don't have enough resolution to be able to tell whether this person is actually unique. And also you're keeping like raw biometrics in the sense that you're keeping like an image of a face. The reason why this is okay is because it's happening on the phone itself. This face image, like this facial structure image that the phone is taken, never leaves the phone. It's this sort of like client-side machine learning algorithm that is doing everything on device. So since it's happening on device, it's fine. But if you want to have this for like a global scale to tell uniqueness, it doesn't work for more than like 10 million people or so, 10 to 15 million people. And also like you would have to store images of people's faces somewhere, which is not great when it comes to privacy. Same happens for all sorts of other solutions, not to mention that your phone, I'm not sure if twins can bypass Face ID, but it's quite likely, mostly because there's not enough randomness between them to be able to tell them apart. Essentially, there's enough people in the world to be able to unlock the same phone. And so if you want to build something that is truly scalable, it wouldn't work. And also something that would be decentralized and privacy preserving, it also wouldn't work either, because you would have to upload your images of your essentially like frontal camera to some service, which wouldn't be really great. because it would compromise your privacy in several ways. And another important part of the orb is that all of the compute happens on device, right? The orb essentially is a self-encompassed system which has a computer, like it has an operating system, it has a CPU, a graphics card, and all of this computation happens on the orb. This is really important because it means that Worldcoin servers don't touch any parts of the biometrics. The only thing that leaves the orb is the iris code. And the iris code is this sort of like uniqueness representation. And then there's some other added steps that I can go into depth once we talk about the cryptography side and other different aspects of the protocol. Cool. So moving forward from the orb, we have the World ID infrastructure. World ID is quite a sophisticated system, not necessarily because it's too hard. There's a lot of like moving pieces that you need to build so that you can actually do these things in a scalable way. So as I mentioned, currently we're in Optimism mainnet. And so the way it works is that when the person goes to the orb and gets verified by the orb, their public key, which is created on their phone, is inserted into a set of verified users when the orb verifies that they're a unique person. And so the way that this is implemented under the hood is that there is a smart contract on Ethereum mainnet. And this smart contract has a registry of all the public keys or identity commitments that are on the World ID verified user base, right? So all the set of verified World ID users. So whenever a user gets verified, they get inserted into the set. The way that this set is verified, even though this set is verified, so essentially you have a set of public keys, and all of these public keys are public keys of users that have been verified. And the way that World ID works is that it allows you to prove within this smart contract that you own a private key to a public key in this set of verified users without revealing who they are. The way that this is implemented is using a protocol called Semaphore. So Semaphore was originally built by the Ethereum Foundation, by the Privacy Scaling Explorations group within the Ethereum Foundation. I'm going to send you a link to where it is. So World ID underneath uses this Semaphore protocol to essentially prove inclusion in a set without revealing which one you are. So this is like how you're able to prove personhood in a privacy preserving way, right? If you walk through the entire flow, user gets verified, their public key gets inserted into the set of verified users. And now that you have a set of verified users, you need a privacy preserving way to prove inclusion in this set. And so the way that is implemented is using a zero knowledge cryptography and this data structure called the Merkle tree. And so you're able to prove that you're part of this Merkle tree without revealing who you are. So this is a really hard problem because also it needs to scale to billions of people. So we've built a lot of custom solutions on top of Semaphore that allow you to do things like batch insertions. So let's say that there's like 1,000 people that have verified in the last hour. You can put them in a batch and update the state of the set of verified users all at once. And there's a bunch of like other different services that we've built around that because there's a lot of really hard problems. Because all of these zero knowledge proofs and all of this cryptography that we're doing happens on the user's devices, on users' phones, because you need the private key to create this proof. And so since the private key is custodied by the users, that's like how you're able to create these proofs. And so there's a lot of hard problems around like having this cryptography be performant, be fast, so that the application is still like easy to use, it's fast, there's not bad user experience, and all these sorts of things. So this is like also like why it's quite hard to build these systems. Another one is this third item that I have over here, this uniqueness service in MPC. I'll go much more into detail for this. Also, there's a presentation from two teams, which is, let me find it. I think I don't have the updated, I don't have the updated one. Yeah, essentially this is the previous structure or table of content. Now these two have merged into one, and there is a third one which is on zkML and multi-party computation. So there's going to be two people presenting on these solutions. But what this essentially means is when you're doing the uniqueness check, like the proving that this person is actually unique, the way that works is that you're checking iris codes against each other, but it's not done in a sort of transparent way. It's not done in a way where the iris codes are public. The iris codes are encrypted, but you're still able to do uniqueness checks on this encrypted version, which is really interesting. This is a really fancy piece of cryptography. I can send you a link to our article on this. So if you're curious and learn something about this before we have a presentation on this from the people who built it together with us, then I recommend you read the article I just sent in the blog and the chat. So yeah, essentially there's this uniqueness service that allows you to prove that you're part of the set of verified users, and this off-chain component to it that checks it's not homomorphic. Homomorphic cryptography or fully homomorphic encryption allows you to do computation on private data. This other part of cryptography called like multi-party computation, that's what MPC stands for, is technically fully homomorphic encryption is a special case of multi-party computation where there's only two parties. So FHE and two-party computation have a lot of similarities, but yeah, it's a different, slightly different type of encryption. If you're curious, I recommend you ask ChatGPT how it works more or less from first principles, or read some articles. We also have a really simple explainer in the blog post. So if you're curious, you can also read that one. But we'll go much more into depth for this in the next couple presentations with Tassio, and we have a presentation from Lucas from Tassio and Brian plus Daniel from Modulus. So they'll be presenting in the future. I'm not sure if it's the next one or the one after that, but really soon there's going to be a presentation on this topic. So you'll be able to ask questions and you'll see more explanations that are much more in depth. And so other than that, there's also this a bunch of other technologies that we're trying to explore, like zero knowledge machine learning, trusted execution environments. The orb itself has this custom hardware that allows you to sign things, and there's a private key in the hardware. Essentially, there's a lot of different types of cryptography and privacy enhancing technologies. That's what PETs stand for. So there's a bunch of privacy enhancing technologies that allow you to do a lot of different things. Also, I have a technical explainer on this. I was on a podcast a few months ago, earlier this year, that if you're a really technical person and you want to learn more about the actual code or how these things are actually implemented in reality, you can also watch this verified user. So your question is, I'm an Android verified user. Can I log in from an iPhone into World App? Currently not. Right now, there's no way for you to recover your World ID within a different device. So if you have an Android, you can only recover it from an Android device because of the way that backups are done. And then if you have an iOS device, you can only recover from an iOS device. But this is a question more for the Tools for Humanity World App team. My understanding is this is how it is right now. I'm not sure if there's a product, a feature in the timeline that would allow you to do these things moving forward. So in this podcast episode, I explained all the technicalities behind how these things are actually implemented on the smart contract level, from the World ID smart contracts to the bridges to other networks, and the developer portal, and how everything ties into each other, all the cryptography and stuff. But I'll also get into this a bit later when it comes to the cryptography explainers that I'll have later, the world chain ones, and a few other things. As we have grown throughout the last few years, there's been a lot of really hard problems that we had to solve, because as you can think, there's very few people who have reached this scale. Not at the moment. Not at the moment, there's very few products or projects that have reached the scale, and especially with such a big on-chain footprint. So with having all these really hard problems, we've had to build a lot of custom solutions. As I mentioned, within the World app, there is a custom safe smart account. So for every user that is World ID verified, you have a safe smart account, and within this, you're able to do transactions, and all of them are sponsored, right? So we've had to build a lot of infrastructure around this. Currently, we're working with the safe team on upgrading the safe. Instead of using a custom private public key for actually signing transactions on the safe, we're gonna update to the standard called passkeys. Passkeys is this feature that allows you to use your phone's trusted execution environment to sign transactions. So the way that you would experience this is that instead of having to use your own private key, you would have to just use your iCloud like passkey authentication, or your Google Cloud, or whatever else you use for passkeys. Is just like you have this Face ID pop up, and you can sign transactions with like your Face ID or with your Touch ID or with anything else. It's a much better user experience. So this is like one of the features that we're building right now with them. We're also migrating to this thing called EIP 4337. EIP stands for Ethereum Improvement Proposal. Essentially, this is the thing that does these features that people call account abstraction. Essentially allows you to pay for transactions in any token outside of Ethereum, because most blockchains take ETH, or most L2s, most scalability solutions take ETH. But if you want to pay, for example, in WLD, or if you want to pay in USDC, you're able to do so as well. And a bunch of other infrastructure that we're building, things like recovery, gas sponsorship, flexible signers. There's all sorts of things that we're working on and we've worked on in the past. Over time, we've also learned a bunch of different problems. Like, we've realized a lot of things about the space and how Worldcoin feeds into the current state of technology in the blockchain ecosystem, and like a lot of things that we've contributed to a bunch of different things. One was that layer 2s or rollups, scalability solutions, were very early, and they're still quite early. Like, they're not ready yet to support 1 billion users, but we're getting there. If you give it like a few more years, there's a lot of scalability solutions that are on the way, and a lot of problems that people are solving, like different researchers, engineers, and we're also trying to contribute our best to that. We had to build a lot of infrastructure ourselves, because very few people have reached the scale that we have. So when you reach scale, there's a lot of problems that come with that, because you need to have still like a lot of robustness, scalability, all these things, and there's very few like projects or tools that allow you to have that. So you have to build a lot of your tools in-house so that you can solve those problems. 4844, this references EIP 4844. So if you're curious about what that is, there's also this website. So EIP 4844 is this Ethereum improvement proposal around scalability. We contributed to this Ethereum improvement proposal, but it took longer than expected. The thing that this enabled is essentially cheaper transactions on scalability solutions, but it took quite long. So we had to, for example, like when we were subsidizing all the transactions for our users, we had to pay a lot during a lot longer than we expected to. There's also a lot of custom transaction stuff that we've done with custom compression for safe smart accounts. And currently, one of the biggest problems that we have is this layer 2 execution gas bottleneck. So the thing that this means is that on layer 2s, there's, again, a fixed set of transactions that you can do on a block, and a fixed set of blocks that are produced per unit of time. Currently on Optimism mainnet, you can do like a block every 2 seconds, and each of these blocks have these like units of gas, and per block the maximum is 30 million gas, and each transaction consumes a set amount of gas. So if, let's say, you have like an average transaction of, let's say, like one transaction is 100,000 gas, and you have 30 million, where you can only do 30 million, right? So you can 100,000 million, right? So you only do 300 transactions that have 100,000 gas per block, right? So this is a hard limit of how many transactions you can fit. And this is for the entire blockchain, like for the entire Optimism chain. So if you want to scale to 1 billion users, you have to get past this limit. You have to enable more transactions per a shorter amount of time by having more execution gas that allows you to do more transactions. So this is the current bottleneck for us. And we're working a lot of this when it comes to research and engineering to contribute to the ecosystem to scale these things. So this is like where WorldChain comes into place. We'll talk about this much more in depth in its own episode or chapter of this Educate series. But essentially what WorldChain will enable is priority block space and transactions for unique humans, right? So instead of having to compete with bots, if you're a unique human, your transactions are going to be included first. This is something that we're working on. It's going to probably take a bit longer because there's so many considerations, because this is touching a lot of the core infrastructure of OP Stack itself. So we have to collaborate together with the other partners within the Optimism ecosystem. WorldChain is going to be open source, permissionless, and secured by Ethereum, right? So WorldChain is just an instantiation of the OP Stack, which is open source. I can also send you the link for that. Optimism GitHub. I can, give me 1 second and I'll find the link for you. So it's using this tech stack. This is the GitHub, but OP stack, maybe there's like an introductory article from Optimism. Yes. This is the one. Okay. So if you want to learn more about the OP stack and what it is, there's also this link. But we're going to get into depth in one of the future episodes that I'll be giving. So WorldChain is also meant to essentially have applications that want to target real users, right? So we have a lot of users and a lot of applications that are building on Ethereum and other blockchains and other scalability solutions. They don't really know who is a unique user within their own user base. So if they want to deploy in a network where they want to target unique users, they can deploy on WorldChain because it's a permissionless network. Anybody will be able to, once we launch, everybody will be able to deploy a smart contract and have it interact with our users in all sorts of different ways. And as I mentioned before, we're going to launch with the World app, right? So WorldChain is going to launch with World app, so you're already going to have a strong user base there. So what is next for WorldChain? Currently, we're thinking about a bunch of different things, but as I mentioned before, the current bottleneck for us is execution and scalability. So scale will be the primary objective so that we can do more and more transactions. At the height of it, we were about 60% of Optimism mainnet. So we consumed about 60% of Optimism mainnet block space. And currently, we need to mitigate that. If you want to scale to, let's say, 5x the amount of users that we have right now, Optimism would not be able to support such a user base. So we're doing a lot of optimizations in different aspects of the stack and launching WorldChain itself so that we can scale this sort of like hard limits. We can support more users and not have to pay more for gas fees. There's a relevant question from Riddick. You mentioned Worldcoin covering the gas fee. Is it still quite expensive after EIP 4844 because claiming grants can rack up a lot of gas? So yeah, it's still quite expensive, but it's like orders of magnitude less expensive than it used to be on Optimism mainnet before 4844. The reasoning for this is that blob space is a lot cheaper and execution gas is now quite cheap. The thing that is also a bit expensive is the data availability side of things. You were paying for this blob space thing, and then also for the execution gas on the L2. The reason why it's expensive is not necessarily because Optimism is expensive, is because we have an insane amount of volume, right? Like if you have millions and millions of transactions all the time, then each transaction, even if it costs a cent, like if you multiply a cent by a million, it's still like 100,000 or $10,000. And if you have like millions and millions, then you still have like millions of dollars worth of transaction fees that you're subsidizing for users. So yeah, there's like a bunch of different things you can do here. But within WorldChain, there's going to be like a native subsidy thing that essentially will also make it cheaper for us to do so, because since we will have the sequencer, control the sequencer in the beginning, because sequencers are not yet decentralized, a lot of the transaction fees that we are going to be paying are going to go to the sequencer, which is owned by us. So it's not negative value that we're losing by subsidizing as currently, because currently we're paying for Optimism, and Optimism sequencer fees go to retroactive funding to give grants to different teams to build an Optimism. So yeah, this is like one nuance. Also, I think I forgot to answer one of the questions from Dinesh. Any possibility for all orb verifications in India? So this is not a good question for me because I'm not on the Tools for Humanity team. The Tools for Humanity team has a lot more context on which market we are going to be expanding to. I know that currently all you can do in the World app is, in the World app, you can choose the country you're in and you can like subscribe for notifications. Really, that's my best tip. You can subscribe for notifications like when orbs come to your country. It's a really hard problem because you need to manufacture hardware, set up operations, expand, grow. And there's a lot of things that come with that when it comes to compliance and all sorts of other topics. So yeah, that's my best answer. Honestly, I'm not the right person to answer that. So yeah, sorry for that. So yeah, WorldChain, what is next? There's this execution client called Ref, which is built by this team called Paradigm. And since we use this programming language, called Rust in WorldCoin for a lot of the things, we are contributing to this execution client to be able to scale. if you have people interested in pitching World ID to a country, who should you contact? At this point in time, we don't really have an established process. This comes more from internally. Like, we do our own internal research, and we're able to assess, or like Tools for Humanity is able to assess which markets to expand to next. The only thing that you can do is, maybe if you want to become an operator for an orb, you can subscribe in the operators page. Oh, I want to become an operator, I'm from this country. And if you put your contact information, people can contact you later from Tools for Humanity to see if you want to share the link. Operators, become an operator. I think it's become an operator. Worldcoin. I'm trying to rush things up because I only have 4 minutes left. So sorry if I'm a bit fast. Let me know if it's too fast, but we're running out of time. I shared the link. Cool. So, and account abstraction, which I'll also go into depth later, is this sort of really important set of tools that would make interacting with blockchains a lot simpler and easier. So I personally, I run this thing called the Human Collective Grants together with 2 teammates or a few other teammates at the Worldcoin Foundation. What this grants program is that there's a lot of really interesting problems that we have within Worldcoin, within the Worldcoin ecosystem, that we don't necessarily have all the bandwidth to solve. And we believe that there's a lot of other people who are much better equipped to solving these problems. And so they're within cryptography, protocol development, and a few others. Some of the problems are listed here, worldcoin.org/RFP, request for proposals. And so they're in different categories. They're within identity, cryptography, infrastructure, and all sorts of other things. So if you're interested in that, you can also check out our community grants program. If you feel like you have expertise in any of these, then you can feel free to apply. And we give these grants to teams to work on a bunch of different ones. And yeah, that is everything that I prepared for this presentation. Hopefully that was good. I will go more in depth into other topics within the other discussions, but hopefully this was like a good introductory presentation. Thank you for listening.
Yeah, it definitely was an amazing presentation. Thank you very much, dcbuilder, and thank you everybody else for coming in and for all of the wonderful questions and interaction which you have provided. Unfortunately, yes, dcbuilder said that we are out of time, but this is only session number 1 out of 8 sessions total. So feel free to join us for the next session on Wednesday on Orb software and hardware, and join us for the following 6 sessions over the next 3 weeks. And I'm sure most of your, if not all of your questions, will be answered by and then. Until then, dcbuilder, any final words of wisdom for the audience?
For me, it would be like, if you want a more sort of in-depth walkthrough of how everything works, because I had to like really fly through a lot of things. It's quite hard to give you like the proper context of how everything works. If you want to just have a not so rushed explanation of the introduction of Worldcoin, because there's a lot of different moving parts, I would really recommend you go through the white paper. I will resend the link here. The white paper has a lot of these different things. If you have questions that you want to ask me during this offline, I also have my Telegram, so you can send me a message here. This is my Telegram profile. So yeah, you can send me any message, or also on X. I'm also active there. So yeah, that's everything I wanted to let you know. If you want to read more in depth about the introductory topics, then the white paper is the best place to go.
Perfect. Thank you very much once again. To everybody else, see ya on Wednesday. Cheers.
Yeah. Bye-bye.